4.3 is using functions involving the number e. Some of the special numbers you've learned in math are the I, the imaginary number I, pi, an irrational number, and today you're going to learn about the number e. If you were to enter the equation y equals 1 plus 1 over n raised to the n power, or use x in place of n, if you plug that into your table in your calculator, then you're going to notice something about the range of the output. The bigger that x gets as it approaches positive infinity, then the output approaches a certain value. So you could say as x approaches positive infinity, y approaches approximately 2.71828, and it's also an irrational number that goes on forever. That means it has a never-ending decimal and it does not have a pattern. So e has a value of approximately 2.71828. Go ahead in your calculator and enter in, usually it's your second button, so second ln, and then you'll notice above the ln that there's e to the x power. So if you hit second ln e to the x, then that will give you e to the, and there'll be a box. If you enter 1 for the exponent and then press enter, you should get this number right here. So go ahead and try that on your calculator. Just remember that e represents a number, it's not a variable. Okay, I've put a couple links on here for some videos. I know you won't be able to click on them because it'll be a recording, but there are a few videos that are pretty interesting on YouTube about the number e. If you're curious, go ahead and check those out. This is just telling you what I told you before. If you enter this into your calculator, into your table, then it will tell you that e approximately equals 2.71828 and so on. That's just a rounding. Okay, so we're going to simplify some natural base expressions. Now, we are going to use the exponent properties just the way we've done before, but apply them to the number e. So when we're multiplying, if the bases are the same, the base will stay the same, and we add the exponents together. So that would be e to the 7th power. Okay, and then this one here, 3, the next one, b, 3 goes into 3 once, into 12 4 times. So on the numerator, you'll be left with 4, e to the 4 minus 3. So your answer would be 4e to the 1st power. Okay, the next one, 5e to the negative 3x, all raised to the 2nd power. Remember that the 2 applies to both factors inside the parentheses. So that would be 5 squared e to the negative 6x. When you have a power raised to a power, multiply. Now we do need to make our exponents positive. So then the e to the negative 6x means reciprocal of e to the 6x. So that would leave 25 in the numerator and e to the 6x in the denominator. So the big idea here is that you're going to apply the properties of exponents to the number e, basically treating it as a variable, but we're not putting that in the calculator. So you'll leave your answer in terms of e, but use the same properties of exponents. Okay, on the next slide is example number 1. I want you to complete that one in your notes and be prepared to enter it in the lesson check. 18e to the 5th divided by 3e to the 2nd. Okay, next we're going to evaluate using your calculator. So in your calculator, you would hit second ln e to the x, Then you enter in your exponent, which is 4, and then enter. So now, if your calculator is different than the ones we use in the classroom, it may be a little different the way you enter that in, but that's basically the same. So if we hit second, and then it's approximate, we're going to round. Let's say we're going to round 3 decimal places. So that would be 54.598. Go ahead and try that in your calculator and see if you get the same answer. Okay, now if on B, it's e to the negative 0.09. Now this number here, because you have a negative exponent, that's the same as saying the reciprocal of e to the 0.9. So that would be 1 over e to the 0.09. But you can still enter that into your calculator with a negative exponent. So again, you would hit second, ln e to the x, and then you would enter in the exponent. In this case, it'll be negative 0.09, and then press enter. Negative. So your answer is approximately 0.914 if we round 3 decimal places. Okay, so if you're asked to use your calculator, then give me the value of e in a decimal. If we back up here, simplify using the properties of exponents, leave your answers in terms of e. Okay, next we're going to be graphing. All of these equations will be exponential growth or decay. So these are natural base. Now that is one thing we didn't talk about. E is called a natural number, and so therefore we call it the natural base. So a function in the form of y equals ae to the rx is called a natural base function, exponential function. If a is greater than 0 and r is greater than 0, so if your exponent is positive and your coefficient is positive, then the function is an exponential growth function. If your a is positive and your exponent is less than 0, which means it's negative, then you're going to have an exponential decay function. So if we look here at your two graphs, this graph here is exponential growth, this one here is exponential decay. The exponential growth has a positive exponent and the exponential decay has a negative exponent. And that makes sense because the negative exponent means reciprocal. So you'll have 1 over e, so 1 over 2.71828. Whatever that is a fraction that's less than 1. So our equation for any function given any transformation would be ae to the r power times x minus h plus k. Again, h is your horizontal shift, k is your vertical shift. Okay, our domain for this exponential function is still going to be all real numbers. The range is going to be y is greater than k if a is greater than 0. It'll be y is less than k if a is less than 0. And then we have one more thing, our asymptote. So our asymptote will still be y equals k. Now we're going to, on the next couple of slides, we'll be graphing, and your graph still will be exponential growth, just like 4.1, or exponential decay, like 4.2. Okay, this is what we just did on the other page. Our domain, all real numbers, asymptote, y equals k, range is y is greater than k, for a is greater than 0, y is less than k, for a is less than 0, so negative. Okay, just make sure you have those in your notes so that you understand. These are the three things you need to have and your table to graph the exponential function. Okay, the natural-based functions. So our equation that we're graphing is right here. Okay, I used I just forgot. The calculator online, the free one, Desmos, the Desmos calculator to enter my table. So this is a copy of that table. So if you enter in your equation into the Desmos calculator, it will give you this output here. Now you notice you're going to have decimals because e is a irrational number, so you're not going to get very many whole numbers. So when x is negative 2, y is approximately 1.819592. Let's, just for graphing easily, let's round that to 1.8, round to the nearest tenth. When x is negative 1, y is 2.3. When x is 0, y is 3. When x is 1, y is 3.9. When x is 2, y is 4.9. So really all you have to do is graph these, plot these points and graph. We know that our h is 0 and k is 0. So my asymptote is y equals 0. So I can graph my asymptote. Because I know that my exponent is positive, then it's going to be exponential growth. So we plot these points, negative 2, 1.8, negative 2, 1.8, approximately right there. And then negative 1 is 2.3, 0 is 3, 1 is 3.9, so it's closer to 0 to 4, right under 4. And then 2 is 4.9. That's almost right there. So we know it's going to be growing as we move to the right, and as we move to the left, it's going to get infinitely close to our asymptote. My domain is all real numbers. The range is y is greater than 0. And that is all you need. So it's really just a repetition of our graphing exponential growth and decay. The big thing is you need to use a table. And you're going to have, it's an irrational number, so you're going to need to round to the nearest decimal, the nearest tenth, to get your approximation to graph. Okay, let's do this one. If we look at this one, is it going to be exponential growth or exponential decay? You can tell by looking at the equation. Okay, your h is 2. Remember, use the opposite sign. K is 1. And is it going to be growth or decay? Because my exponent is negative, it's going to be decay. Which means when you graph, your graph should look similar to that. Okay, so let's make a table. Enter the equation into your table. Go ahead and do that. If you have your calculator, just do it right now together. So you'll do second ln raised to the negative 0.75, and then use your parenthesis, x minus 2, close your parenthesis. Make sure you arrow out of your exponent, and then plus 1. Okay, the number, the y value that's going to fit on our graph, when x is negative 1, then y is 10.4. So that's going to be off of our graph a little bit. Now go to 0. When x is 0, y is 5.5. 0, 5.5. It's a little high. Yeah, close. Alright, 1, when x is 1, y is 3.1. So 1, go to 3.1, barely above. 2 is 2. And 3 is 1.5. 3 is 1.5. Now remember, let's back our asymptote is always y equals k, so that will be y equals 1. So my asymptote is going to be right here. So we know that as we fall, moving to the right, oops, I missed the points. It's going to get infinitely close there, and then we're going to rise there, which matches our prediction of our graph right here. So my domain is all real numbers, and my range is y is greater than, but not equal to, so just greater than 1. And there's your graph. Okay, next is your example number 2 for your lesson check. Make sure you understand how to put these into your table. You'll be using your table a lot. And make sure you understand if it's going to be growth or decay. And be able to graph your asymptotes. Please graph your asymptotes on your homework. Show your graph, domain, range, and your asymptote. Okay, example number 2. What is the asymptote of this function? F of x equals 5e to the x minus 7th power plus 3. Okay, we have another equation for you. Remember 4.1, we had the compound interest formula. 4.2, we had the continuous, we had decay. We had the decay formula. And then in this lesson, we have continuous compounded interest. So if we look at that here, your equation for continuously compounded interest is A equals P times E raised to the RT power. The key for using this equation is if it says it's compounded continuously. So when you read the word problem, that's one of your key words. If it's compounded monthly, daily, weekly, then you use the compound interest formula that we did in 4.1. If it's continuously compounded, we're going to use this one. Remember, P is your principal. Oh my goodness. Okay, P is the principal. That's the amount you're starting with. E is just a number, so you're going to use your calculator for that. Remember, R is your rate as a decimal. And T is time in years. So here's, let's use this example here. You deposit $4,000 in an account that pays 6% annual interest, compounded continuously. There's your keyword. That means I know I need to use the formula A equals P times E raised to the RT power. What is the balance after 1 year? So I need to know what my P is. P is my principal, and that is $4,000. We need to know our rate. Our rate is 6% interest, which converts to 0.06 if you divide by 100. T is your time in years. We need to know that after 1 year, so T in this situation is 1. So if we plug that into the formula, we're going to get 4,000 times E raised to the 0.06 times T, which in this case is 1. Then you just have to plug it into your calculator. So 4,000, second ln. And then make sure you use parentheses here if you're entering that into the calculator. This one will just be 0.6 because it's times 1. So your answer will be approximately, remember it's money, so use your notation, $4,247.35. Make sure you round to the nearest hundredth, since we're dealing with money. Okay, now you have 3 formulas. Make sure you know when to use which formula. And the next slide is example 3. You deposit $8,500 in an account that pays 4% interest compounded continuously. What is the balance after 6 years? Please calculate that amount and be ready to enter that answer into your lesson check. Round your answer to the nearest dollar. Okay, that is the last thing. There is one more slide. Sometimes you guys see that. Let me show you real quick. It's just the book assignment. Had we been in class, that would be the assignment you're doing. So when you see that, it's really nothing for your lesson. This is the last one, so go ahead and do your lesson check and then work on your homework.